Okay, I think it's recording. Yeah, it says it's recording. Okay, great, cool. So again, everybody, welcome to the final session of the Android Study Jams. This is the final. This is the session 4, the last session. Hopefully, everyone's had a chance to kind of go through some of the code labs that they presented, and are kind of familiar with all the concepts. But don't worry if you don't understand all the concepts and everything. We're kind of going to go through that, and like I said before, feel free to ask any questions that you might have to any of us. So what are we going to learn about in this session? So today's session, first thing that we're going to learn about is the repository layer. Now, this is probably one of the more important things that you can kind of learn about app development in general. Repository is a very common pattern that is used everywhere. And essentially the pattern exists so that it is much easier to handle your data operations. So when you have an app, you're going to have the part of the app that everybody interacts with. You have the UI, all the buttons, all the widgets, and all the the views that you're going to be using. But more importantly, behind that, you have your data, and your data is basically what's really going to be driving your app. Whatever you're going to be displaying, whatever user input that you take in to display other data, it pretty much all goes down to data. And so it's really important to have this layer written in a way that you can add a lot of stuff to it. It's scalable, it's easily testable. You want to be able to have a maintainable code base, especially because the data part is going to be driving your app. And is possibly more important than any other part of your mobile app. So the second thing we'll be discussing is Work Manager. Work Manager is kind of a unified API for scheduling different tasks. Android has been around for a while, and unfortunately, over the years, they've kind of changed this around a lot. It looks like they've kind of settled on having this Work Manager API to help people basically schedule recurring or time-based tasks. The third thing that we'll talk about is material design. So material design, being able to style your app and kind of provide a lot of more functionality based on a design guideline. And kind of introducing some of those components into your app. And then finally, I'll mention a couple things about testing. Now, there's a lot of stuff that we're going to cover this week. So I'm probably going to be focusing a lot more on the repository section, because that does tend to be a more important section. The other 3 parts are also topics that I could spend an entire evening discussing. So I'll probably not discuss those quite as much, but do feel free to ask any questions or bring up any comments about any of those other sections that you might have specifically. But yeah, that's how that's how this is going to be structured today. So a little bit about me. I guess maybe I should have switched those 2 slides, but like I said, my name is Jin Kim. I am one of the co-organizers of the GGG Boston Android group. And I have been a developer since 2005, and specifically a mobile developer since around Android 2.3. So maybe it's been about 8 or 9 years or something like that. Geez, yeah, time flies. I can't even keep track of how long it's been. But yeah, I've been doing this for quite some time. And currently I'm working as an Android developer at Teva Pharmaceuticals. It's one of the largest pharmaceutical companies in the world. They make a lot of generic medications. Basically, when things come out of patent, Teva will start producing that drug for a lower cost. And I work specifically in their digital health initiative. And in the digital health initiative, one of the things that we work on is we have a Bluetooth connected inhaler. And so I work on the app to connect to this Bluetooth inhaler, and using the computerized components inside the inhaler, we could tell a lot of different things about how the patient is using their asthma inhalers. And a lot of that data that we collect is used in order to make sure that people are taking their medications on time. And you know, we can tailor their medication, their prescriptions to their particular condition. One of the unfortunate things about medication, there's a lot of different medicines for asthma, but you know, to help any given patient, you might need to try a lot of different things. And for a long time, that was a manual process. But you know, thankfully, with the innovations in mobile and innovations in Bluetooth and connected devices, we can kind of start building systems that can automate a lot of these processes, and we can hopefully learn a lot of things about our patients. I've also been an organizer of GGG Boston, so you know, I do a lot of conference speaking, a lot of teaching. I think between the two, I kind of prefer you know, this kind of teaching. Conferences can get very, you know, you're talking to a very large crowd of people, and you don't always know if things are resonating. But with a smaller group of people, you know, it's much easier to get that, you know, to get that feedback. So please ask. So yeah, some questions. Yeah, it looks like somebody's already asked a question about MVP, MVC, MVVM, and MVI. What's popular and recommended? I think so the four things listed there: MVP, MVC, MVVM, and MVI. Those are architectures that that people in the Android community use in order to structure their app, and also how the app communicates with the different parts. You know, how data goes from the data layer, which I'll be talking about in a second, the repository layer, and how that information gets propagated up to the UI, so that the UI can reflect, you know, that data and also accept user input to display other data. I would say use one of these. When you're building an app that's going to be scalable and have a lot of different components, you should definitely use one of these architectures in order to develop your app. All four of these are basically different approaches for doing exactly that, getting the data and having it interact with the UI. And so as far as what I would recommend or what's popular, one thing that I've always kind of shied away from answering is which one would I use for any given project. And the reason for that is that engineering is a lot about trade-offs. And so when you choose to do something, or when you choose to write something in a particular way, you're making a bunch of other choices down the line as well. And so you really need to take a look at all of these architectures and kind of determine what you need in your app. Remember, at the end of the day, a lot of these things that I'm going to discuss, at the end of the day, it's up to your particular needs for your app. And so that rather than recommending anything in particular, it's probably a good skill to have to be able to recognize the things that you're going to need eventually, and also which one of these will match that particular need that you have at that moment. For example, like some of these architectures do a lot more than the others and are a lot more powerful, but because in order to get to that, you need to write a lot more code to handle a lot of other things. And there's also questions around, you know, readability, maintainability. What are the other people on your team? Most of us are going to be working at as part of a team when you're doing software development. So it's probably good to recognize that these are all about kind of trade-offs. One person is asking what the most basic is, the starter one. I would probably say MVP, Model View Presenter, is probably the more simpler of the models. MVC, I would probably lean away from. There's a lot of, in the world of Android, I feel like presenters are a more accurate thing that you want to do rather than a controller. But I have seen architectures that kind of use the MVC pattern before, and but that was kind of more in the early days of Android. I think if you want to start somewhere, I would definitely start with MVP and kind of understand how that works, and then quickly kind of move on to MVVM. There's a lot of support in Android right now for view models, but in order to get the idea of what it is that you're trying to accomplish with these architectures, I would say you start with MVP, and then once you kind of have a good understanding of how that works, move into MVVM. And if you need something where you need a lot more control over what you're going to want to do as far as interactions with data and your UI, then check out MVI. MVI is probably the most complicated, but it's also the most powerful. It really gives you a lot of control over what particular states your app is currently in, and that has a lot of implications for being able to test it, being able to understand how reliable it is. And so, yeah, I would say those three are probably the ones that you want to focus on in that order. But MVP and MVVM are probably the ones that you want to start with. But MVVM is officially kind of supported. There are some components that'll help you write an app in MVVM. But very good point. Roman has a very good point where, you want to match your needs to the architecture and not the other way around, because then you just end up doing a lot more work for not a lot of benefit. And because these are architectures, these aren't language dependent. These are architectures that you'll find in a lot of different other situations. Web also uses, they have their own particular architectures as well, but it's all kind of depending on the platform. If you guys are familiar with some iOS development, you might hear them talking about something called Viper. That's just another architecture for how to lay out the interactions between your data and then the UX that you want to present to the user. Very good question, but there's a really lot of things to go into it, and if you want to continue the discussion on those, I won't be focusing on them today. But if you want to ask more questions about that, please in the Slack or in the chat. I'd love to continue talking about that stuff too. I'm kind of surprised actually that it wasn't included in this code lab, because it seems like it's a pretty important part, but there's only so much time to talk about this stuff. So let's dive into the first topic, and what we want to kind of spend a lot of time today talking about is the repository layer. So what is this? What is the repository layer? So you have two components in your app, right? You have the UI that everyone interacts with and kind of displays the data and lets you interact and manipulate that. And then you have the other side where you have the data that you want to store. Now, the data that you want to store can come from a lot of different places. Most commonly, it's going to come from a RESTful call to an API somewhere out on the cloud, right? For example, if you want to go find the weather, you go to some weather API, and then you send in the parameters that you want, and then you get back some sort of structured data that you can use. Taking that structured data and then being able to manage that within your app is really kind of key, because the way that you do that influences how your UIs will also kind of respond to that data as well. And the repository layer is basically that. It is the repository for your data. You can also kind of, there's other sources of data. That's probably the most common one that we'll cover today is basically going to an API call on the web, fetching something, and then being able to store it on the device, and also kind of signal the UI that you want to, that you have this data that you want to present to the user. Repository modules, simply put, handle data operations. All the things that I kind of described with going and grabbing some information and using it in your app, the repository will do that all for you. You know, your data can come from a lot of sources. Even the device itself has a lot of different sensors that you can collect data from. You can kind of route that all through your repository as well, depending on what kind of data it is. For example, like at work, we have this Bluetooth module that continuously is sending us data. So that is another source of data that we need to store and manage. We also have things that are coming in from the web. So that also comes into the repository, and then that's where we kind of store and manage that information so that it's readily accessible by the UI or other parts of the app that might require it. So if you have one layer for your UX, which the architectures that we were discussing, the MVVM, MVP, MVI, those kind of handle what happens with the data to the UX side, and the repository handles the data itself. You can think of it that way. And whether or not you architect your app as with a repository pattern, you are still retaining data. So it's no matter what app you're working on, you will most likely have something of a repository module that is handling all of your data that's kind of separate from a lot of the other concerns that your app might have. So as I was alluding to, this is kind of the general, this is just a general overview of what a common app will look like. So at the top here, you have your activity and fragments. That is your UI layer. That is the screens that your user is going to be interacting with. Underneath that, you have a view model. Somebody let me know if, so how much of view models have been covered by this code lab? They kind of go over it a little bit, right? Or have they read class?
Yeah, last session we spent some time on view models and live data, but
okay,
feel free.
Yeah, okay, just to recap really quickly. So your view model is basically the model of data that is connected to your activity or fragment, and live data is just a way to facilitate updates to that system. So the view model will get its information, and when that happens, it will update the activity and fragment. Now, where does that view model get its data from? The view model in this case, it will get it from the repository. And under this repository, you can see that there is a model. Models are basically your plain Java objects. I guess in this case, it'd be more Kotlin objects, but these are your plain objects, right? So we go fetch something from a weather API. So we're probably going to have a bunch of fields like what city you're in and how sunny it is, and if it's going to rain, and the temperature and all this other data, right? So basically you just store that into, say, a weather object that has all these fields that you can just store these in. And then underneath the model here, this is all going to be stored in your app into a database. So on this half, on the left-hand side, this is where your data is being stored in a database locally. And the reason why we want to use a database is because it allows you to kind of structure your data. It allows you to use a lot of Basically, if you're familiar with SQL, it basically allows you to use a relational database model within your app in order to manage your data. And that is a good scalable way of kind of storing everything locally on your device. There's other places that you can kind of store things like the file system or shared preferences, but most commonly, at some point you will want to use something like a database because it just provides you with so many useful tooling for accessing a SQLite database. And also it's kind of built into your app anyways. You have access to a SQLite instance. So yeah, it's an excellent way of kind of managing your data. Now, where does that data come from? Well, on the right-hand side, you can see that we have a remote data source. And that remote data source is most commonly going to be a web service. So, you build your URL, you go make your GET call to some sort of a web service, and that web service is basically has a contract with you to provide you with some data in a particular structure. And this is so the right-hand side pretty much represents fetching the data from the internet or from whatever other source that you have outside. Now, there are differences in how these two operations work. For example, you have a database that's local onto your device. You're always going to have access to the disk and the database is going to live on that disk. So no matter what, you will most likely have access to a database and be able to pull data from there and be able to present something to the user. Now, the right-hand side, this remote data source, a lot of things can kind of go wrong with that data source. What if your internet happens to be down? What do you do then? What if the API that you're calling is currently down? There's a lot of issues that you run into when you're trying to pull data from a remote data source because it's not there. So in that case, what do? You still want to show something to the user. You still want to be able to have them interact with your app, but you need a way to kind of store that so that somebody can still do things with your app while you kind of try to figure out what's going on with the web service or whatever. And so that's where a lot of this information, that's why you want to have a repository layer. The repository layer kind of manages a lot of that stuff for you, right? So you have the information that's in the database, but that could be a little bit stale. The information that's on the web surface is the most recent and up to date, but that one is prone to failure. So a lot of the logic that you'll have for managing these two components and how they work with your app is going to be living in this repository layer, and that's why I feel that this is one of the more important components that you could write for your app, because it allows you not only to have an experience to provide an experience to your user that's very smooth and seamless, and but is still capable of doing as much as you possibly can, even though you might not necessarily have an internet connection at that given moment. Does anybody have any questions kind of about this repository overview? And this is something that exists in a lot of other systems too. Websites will also use something like a repository pattern to kind of manage what's going on. It's a little bit, because in the mobile world, we have these devices and they're kind of separate from a lot of different things that a computer would have access to. Like, for example, you can always put an Ethernet cable into your computer. You can always, you always have power, you always have internet. So, certain things that you can always rely on a desktop setting might not necessarily exist for mobile. And so that's, why repository is kind of more important in this case, because you're on this small device that kind of has they're getting a lot more powerful, but they do still have these, physical limitations. But we want to still be able to code apps that still can respond to the user, even though you might be running into these issues. Yeah, basically, so in this case, one person was saying that we store it in the cache. Yeah, basically your database is acting as the cache for the data that you're trying to pull in from the web service, and you are trying to you basically want to put it in something, and the database happens to be the best thing to put it in. But you also probably will have some logic going, kind of in your repository layer saying, okay, try to get something from the web. If you run into a problem, pull it from the database, pull it from the cache, essentially. And then display that to the user. And meanwhile, we'll still try to get the information from the web if the web service comes back up. For example, maybe your Facebook, and we're back at last Tuesday, right? While you can't get anything from the web, we'll just show this stuff that we've cached onto the we'll pull up the stuff from the cache and then display that to the user. Yeah, so the second question, room and retrofits. Yeah, so that is repository as a concept at a high level. Room and retrofit are libraries that are available, and I'll be talking about these libraries in a little bit and look at a couple examples of stuff. But these libraries are basically libraries that have been created to help you access, like for example, Retrofit is a library that helps you access web services. It kind of pulls in a lot of different stuff that you need in order to access something on a web service, like building a URL, different configuration settings. Yeah, it kind of takes all that and kind of wraps it into this nice library that kind of does it all for you in maybe 1 or 2 lines. Same thing with Room. Room is, so way back when people started doing Android stuff, we would have to write SQL statements and save them as strings, and then use that to, make your queries into your database. But that can be a really cumbersome, task, managing all these strings of SQL statements. All you have to do is misspell your table, and you're kind of staring at your app and wondering why your data is missing. But the table is the same as the model name, is the same as the database name. It gets very confusing. So Room is a library that Google provides that allows you to simplify that process. And so those two things are just libraries that help you kind of access either the database or web services. Yes, yeah. Room helps you. Room helps you turn your database into objects that you can readily use, and then Retrofit turns web services into objects that you can readily use. And those objects are the things that are going to be what you're passing up through your view model into your activity. So. Yeah, that kind of facilitates some of that. And then, you don't have to do a lot of this manual stuff. Like, for example, with Retrofit, before the advent of Retrofit, you'd have to construct your URL as a string. And there's a lot of places that you can make mistakes in, and it's not a very scalable solution. If you have 20 different URLs, that's 20 different strings that you're modifying or, having to update and maintain. It quickly gets to be a nightmare. And on some of these apps, you're accessing all kinds of APIs very rapidly, and you just need a way to just easily map those things over. And we'll look later on in this, we'll take a look at some code for doing Room. So yeah, any other questions or kind of comments about repositories? If you have an offline app or a local app, is there a benefit or a use case for a repository layer? Yes, but your repository layer won't be as complicated. In this particular case that we're looking at here, we have a remote data source and we have a local data source, But if you don't have that remote data source, your repository is basically going to be kind of like a pass-through layer from getting stuff from the database, and then when you get the model, then you pass it to the repository. And remember, your view model shouldn't necessarily be accessing the database itself. It should be accessing it through a repository. And the reason why you want to kind of abstract these things out is partially for testability, but it also makes it a lot easier for your component, for you to understand what your components are doing when they're when what they're doing is a very simple thing. So yeah, you will still need a repository for your view model so that your view model can still pull information. And even with local information, there is some logic that you will want to put in there. You might want to have like error handling, or just if you do end up having sort of a adding in like a web component onto it, eventually having that repository makes it much easier to kind of write that as well. Also, even in an offline app, if you're pulling information and data down from, say, the camera or some sort of sensor that you have on it in your phone, like a barometer, you still want a way to be able to take that data that you're collecting from the sensor and being able to store it in the right place. And doing that through a repository is preferable to just handle, rather than just handling the database directly. Any helpful libraries for using repositories with TCP/IP, i.e. managing connections or data? Yes, so on the right-hand side, you see that there's Retrofit. Retrofit actually has a lot of, that kind of built into it. If you need a lot more control, okay, HTTP3. So you can actually, even into Retrofit, you can provide it different HTTP clients as well, because there's a lot of variation in the types of clients that you need to use in order to make your API calls. So yeah, Retrofit allows for a lot of different kind of modules and other things that can kind of help you with error handling and managing different connections, but it's mostly kind of revolves around a RESTful API calls. If you have some other needs like UDP or like if you're streaming data, you might want to look at some other libraries to handle that particular case. But Retrofit is especially good at doing RESTful API calls. So if you have anything a little bit more complicated than that, check to see if Retrofit does allow you to do that. And if you can't, you might have to kind of write your own components using some of the ones that are built in the networking layer of the Android system. Okay, so okay, so I've gone over what happens on the left-hand side with the model and the database, and I've gone over what happens on the right-hand side with the remote data and the network. And so the repository layer is in a way providing an API for accessing both. So in the case that I was saying before, where you're kind of pulling information from a weather API, so you want to have a method that's something like fetch weather, right? And that fetch weather method will go out and get information from either the web service or from the model. But you're basically writing an interface. If you're familiar with interfaces and how they work with Java and Kotlin, an interface is basically a contract, right? A contract is basically a promise that when I ask for this, you are going to give me this back without fail. And so at your repository layer, you write a fetch weather call, but depending on whether or not it's coming from a web service or whether or not it's coming from the database, you're going to be doing different things. So Another way to think about this repository layer is it's a layer to make the stuff that goes on at the database level and at the web service level transparent. Your app, your view model shouldn't really care about the database that it's working with, and it shouldn't care anything about the web services that it's accessing. The repository, this fetch weather method that your view model will call will figure out that part for you, you know, for the activity and fragment. It's not any of their concern where this information is coming from. So in a way, you can think about it as you are basically building a mini API for your app and asking and providing different logic for your app. And that goes into why you would want to use a repository. You want to have this separation of concerns between these components back here. You don't want your repository to care what's going on at the, you don't want that to care anything about your UI. And you also want to be able to, you want to do that because at any given point, a part of your app can change. You could get new requirements, you could find a newer way of doing things, and you want to be able to just swap these things out and not have to worry about what kind of effects it has with the components around it. So for example, back here, say you don't particularly like the room or the room library, right? You want to be able to swap that out. Suppose you don't necessarily like view models, for example, or live data. You can take any of these components and kind of swap them out because they're all kind of separated. They're all kind of abstracted away from each other. And so these components kind of come together in your activity and fragments. Activities and fragments are really just glue to kind of bind all of these things together. As probably has been explained as a lot of you have found out, activities and fragments can be kind of very fragile. So you don't want these things to be so tied in with your activity or fragment that having the UX layer get killed off randomly because of constraints on your phone. Or rotation of device, or any of these other things that can cause your UX to get destroyed and rebuilt. You don't want to tie your data to that, right? You don't want your database to go down along with it. You want that to live in a separate part because that is a separate concern from what the UX is doing. UX is going through all kinds of changes and it's going through all kinds of updates. And you don't want that to affect your data. And so you put all of that stuff behind this repository layer. And then when you put all that stuff behind the repository layer, your data gets fed through there and then can be sent up reliably to the UX because the UX is the part that's really flaky. And so if you're not rebuilding things that you don't have to necessarily rebuild. And your UI is kind of driven by the data. So you have this flaky UI that's driven by this data, this data layer that's kind of, solidly there, and it kind of persists throughout your app. And that's kind of the importance of having the separation of concerns, so that each component of your app has one job and one job in particular, and that's all it cares about. And that makes it a lot easier to reason about your app. And also when other people are reading your code, they understand that, oh, this only concerns, the repository only concerns data. We're only talking about data, right? So there are certain things that these architectures can kind of communicate without necessarily, communicating explicitly. And finally, the real benefit of using a repository is just because you're building this API for your data, and you can test all of these components separately and make sure that each component does exactly what it's supposed to do, so that when it comes together and you start doing integration tests, you know exactly that all your components should be doing exactly what they're supposed to be doing. There could be issues at the integration layer where, you know, certain things aren't moving quite the way that you want them to, you know, certain data is getting lost or whatever, but you can identify which component is having that issue a lot easier when things are separated out. You know, apps can get very, very complicated. They can get very large. You can have a lot of data sources providing data for your app. Separating all of that kind of stuff out into its own particular issue allows you to isolate things, and just, it helps so much with debugging and helps so much with writing test cases. And having that architecture allows you to also make a consistent structure for everyone to kind of follow. Does anyone have any questions on why you would want to kind of use a repository and about some of these concepts? Have they covered all the issues that you can kind of get into with activity and fragments and life cycle and all of that? Because yeah, that's, you know, one of the reasons why repository pattern became very popular in Android is because our UX has these kind of, or the UI layer has these kind of very interesting issues that other frameworks might not have. Okay, moving on then. So a couple other concepts that I just want to introduce right now that'll help you with repository. These aren't necessarily concepts that are clearly covered by the code lab, but these are things that you should be kind of aware of when you're talking about a repository layer and how you're kind of building and designing it. So one other topic that I'm not sure that they've covered all that much is, so you have the view model and you have these repositories. How do you link those two together? How do you provide that dependency of the repository layer to the other parts of your app? And so you'll hear a lot of stuff about dependency injection. A lot of times when you have repositories, you will use dependency injection or service lookup in order to be able to fetch those components when you need them. The naive approach for a repository is, I guess you could take your main activity and dump all your repositories out and just have them available to all parts of your app, but then that would violate the separation of concerns thing. So once you've kind of figured out your repository, you want to also decide what your strategy is for being able to fetch these repositories, you know, on the screens that you need to. So you'll hear a lot about dependency injection, and the difference dependency injection and service lookup is basically just saying, hey, do we have this component that we need, this dependency that we need? Do we have a copy of it in the app that we could use, or do we need to create a new one? That's basically all it is. And the difference between dependency injection and service lookup is whether or not, so in dependency injection, the dependency injection also has access to constructors too. So if they cannot find a copy of, or if they cannot find the object that you're looking for, then it knows enough to create it on its own. Whereas in a service lookup model, all of your dependencies are created up front, and all the service lookup needs to do is just find the appropriate dependency that you need and just provides that. So you know, they both kind of try to fulfill the same goal of being able to provide you with your dependencies when you need them. So you'll hear a lot of this stuff about dependency injection and service lookup. That's all it is basically a way for you to get your components, for example, like your repository. The second thing you might want to consider when you're talking about a repository is how you want to structure this. There are a lot of different ways that you can kind of build your repositories. One of the more popular ways of doing it now is by using streams. And basically a stream allows you to basically move data and transform it and do a lot of operations to it as it moves from one part to the other. So in the case of the repository, you know, you will have streams and observables that kind of signal when things have happened. Like, for example, I've successfully retrieved some information from a web service. The stream is going to notify other things that are observing that stream and say, oh, we just got some new information. Let's process that information and get it ready to send it up to the view model. And then that can be another stream. And so you want to kind of figure out what components you want to use in order to, build your repository layer up with. And observables and streams and having view models that kind of observe the data is one way you can kind of get your data moving. So there are some decisions that you'll have to make there. And finally, ORMs. Oh, so in the previous case, we were looking at Room. Room is just the library to help facilitate getting from your database to your object. But there's a lot of other libraries that have existed. Room is probably one of the more recent ones. It's probably a good default to use that if you want to use it, but there's a lot of other ORMs that might fit your particular use case a lot better. For example, at work, we were using something called Realm. Realm kind of takes your database and provides you a lot of the boilerplate to provide you with Kotlin objects, so that you can use it in the rest of your app. There are some downsides and there's some pros and cons with any system that you use. For example, Realm was single-threaded, so we ran into some performance issues, but it did handle kind of a lot of the boilerplate code that we would have had to use to write ourselves otherwise. So you have to trade off, and you have to kind of weigh your options and kind of make decisions on that. Any questions on any of these kind of things? They didn't really talk a lot about them, and I'm kind of going over them really quickly. But yeah, these are also things that kind of are related to repositories that might be kind of important. Let's see. Moving along. So databases. Yep. So I think I've covered a lot of this stuff, but just to go over really quickly. So the database is essentially cache. The Room library is just the default ORM, object relational model is what ORM stands for. And basically, it allows you to take a database and get it to spit out plain objects. Another thing that you probably want to look into is also a database refresh strategy as well. How often you refresh your database and how often do you do writes to it. And a lot of that kind of stuff comes with, as you work with databases, you'll kind of learn a lot of this kind of stuff. And this is applicable to other databases, technologies as well. And then also observables being kind of like a really good way of, observables and streams being a really good way of being able to signal to other components that things have been updated on in your database or your repository. So let's see, really quickly, let me just switch. Maybe I don't need to. Okay, so basically, Room, so when you have a database, you have tables, and you have which kind of store your data, and then you have operations that you can do on those tables. And so these are the attributes that you would use, or these are the annotations rather that you would use. And basically, the way that Room works is that you will just simply tag, different components of your app as with these annotations, and that basically signals to the Room system that it needs to generate some code that code is what these things kind of map out to. So, for example, with entity and column info, entity is your table that you're storing everything in. Column info is just things that it's matching up the object to the column name in case your column name doesn't necessarily match up with the object name. DAO is data access object. So basically, this is the object itself. You're gonna annotate that so it knows that when you say, "Oh, I want a weather object," you tag that with DAO, and then it'll know that when it pulls that object out to put that into that weather object. And then you have your CRUD operations of insert, delete, update, query. Basically, you annotate the function that you want to use whenever somebody calls the end of these functions. So yeah, basically it's an annotation-based system. So you're just marking up the different parts of your app. Let's see. And the final thing that I kind of want to emphasize is don't forget to test. The reason that we're doing a lot of this stuff is not only for the separation of concerns and getting a good architecture and having a scalable, readable app and all that stuff, but the other thing is the only way that you know that your app is working and the way that you know that incremental improvements that you're adding to the app aren't breaking old things and just, you're keeping your users happy and you're keeping your developers happy. Tests. All the components that I've talked about, please seriously consider writing tests first. And this advice kind of is dependent on what your team or what you're comfortable doing as a strategy for testing, but please do, take advantage of that a lot because that is kind of,
yeah, writing your tests first is something called test-driven development. And that's kind of an interesting camp and school of thought. One of the reasons I want to do these study jams is so that I have time to write tests, so that I can have the time to do good unit testing, and so that unit testing is a priority because we're not strapped for resources and developers. It's not a luxury. It really helps a lot with the quality. So I just wanted to chime in and emphasize there's some code labs on testing for Android, and you should follow up this course with those labs, okay?
Yeah, a lot of these concepts that we aren't covering in depth, we will try to cover in future sessions. That kind of stuff is TBD, but please keep watching for kind of new announcements for other courses where we will kind of go into these things a lot more in depth. But yeah, I'm not doing some of these topics justice. And test, yeah, definitely is a topic that a lot can be said about it. So moving on. Oh, okay. So here's an example of root. So you can see that we kind of have these interfaces up here for how, the ways that we are going to want to access these videos. And so, for example, this query here is getting all the videos here, and what it's returning is a list of database videos that are wrapped in a live data object, and that live data object will be what helps you kind of send updates through to your UX layer, your UI layer. Same thing if you do an insert. And so you can see, you're kind of just defining a lot of what you want to happen, and you're just kind of tagging these with these annotations that allow room to know that these are kind of the specifications. And so I believe that what we'll do in the background is that it'll generate some code for itself using code generation and kind of generate the code that it's actually going to be running when you run these. So this makes it much, much easier to write these things, because you're kind of just tagging these things. And these are some more examples of this tagging here, where we're kind of just defining these this database video as an entity, and that allows us to kind of pass these things back and forth using the Vim library. And link to the code labs. Yes, here. This is a link to. Okay, this is a link to the material design code lab, but I think that'll get you to the other ones as well, unless somebody can give you. Oh yeah, that one is the better one. That's the more general one.
I got that's the repo code lab, and here's the kind of high level index of all of the code labs for this study jam. So we have a link in here if you wanted to demo and compete for the Pixel Airbuds. There's a link here in the chat. And so far we have 2 people who are going to demo. And then we also have door prizes. One more pitch. I think Jen has a few more things to say, but the form that's pinned, if you want to get some Boston Android stickers and your completion certificate mailed to you, just include your snail mail address. The stickers look like that. It's our Boston Beanpot or Beantown sticker for your laptop. And yeah, back to you, Jen.
Yeah, I guess my link isn't working. The other link that Beth sent, and a couple other people have sent, that's the one that's going to lead you to that one. That one, the one that I sent, are just for the material design. But yeah, you'd have to navigate around to get to the main page anyways. Okay, so now that we've gone through kind of the database side, we'll quickly go through some of the kind of the network side. Fortunately, the network side is a little bit easier to discuss, because we do have libraries that can kind of take care of a lot of this stuff for us. But yeah, basically in this scenario, your network calls are basically calls to REST services. You can do a get, you put, post, you can do all those operations. And the way that it's most commonly done in Android nowadays is simply to use these 2 libraries, Retrofit and Moshi. Retrofit will take the arduous tasks of kind of constructing the URL and then providing an HTTP client and then sending that URL call through the HTTP client and then waiting for the response. It kind of handles all of that in one kind of very convenient object. And that Retrofit also accepts a lot of other kind of libraries to do, for example, Moshi, which will take your JSON objects that you get from your network calls and turn them into models. So you can provide a instance of Moshi to Retrofit, so that Retrofit will use Moshi to, once it gets that response back, it will run, it'll run the JSON parser on it. So at the end, you just get the model of what you want from the network. So in a lot of cases, you'll see that the network layer part for the repository really just consists of Retrofit calls that match up to the REST calls that you want to make. And so that's one way that it kind of helps with your architecture, and also kind of helps a lot with reducing your boilerplate. Every Retrofit function that you call should match up with a particular call that you're making to your web service. And then because you provide Moshi, and there are other JSON parsers. Moshi is probably one of the more popular ones, and probably one of the more frequently updated ones too. Yeah, with the combination of the 2, you can basically in a few lines go from web service call to your data. You can also use observables here as well. You can use an observable stream in order to You can have your retrofit calls return a stream of objects that you can have other parts of your app. For example, the repository can observe the network stream, and whenever the network stream finishes making its call and returns an object, then you can notify the other parts of your app that have an observable that is watching that stream and can then run its own code to update things. And you'll see this in your view model. This is kind of like another way of doing the live data part. If you want to have that level of control over your components, you can basically use these observable streams. And I believe that streams are built into Kotlin. Correct me if I'm wrong, but yeah, Java didn't really have great support for streams, so this was like kind of added on initially with the RX library. If you hear about the RX library, is basically a way of doing observables and streams, and it's a really powerful library, but it's kind of complicated for a lot of use cases. So there's a lot of other options that you can use now, live data being one of them. But I believe that like Kotlin and a lot of languages nowadays kind of have streams and observables built into their standard library. Yeah, here's an example of kind of the service layer, and a lot of this code is just code that I pulled right from the. I believe that when you go through the repository code lab, there's like there's a link to a completed code base that kind of has all this stuff. But as you can see here. Basically this dev byte service is our service that goes and connects to the web service and pulls all our information down from the web. So you create a new retrofit instance and you provided the base URL, with the domain. Here we add the motion converter factory, which is the factory that the retrofit will use to turn the JSON into objects, and then you just say build, and then you create this copy of this interface here, which is your get here for getting the playlist for your network videos. So this here is a basic example of a network call. So. Yeah, these are just, and this here is just to highlight that, you just have a data class here for the network video that just has all your fields in it. And that's what this network video list here that you create is what you're trying to receive back. So yeah, I would say it's less code, but than the database part. But you can use a lot of similar kind of things here. So we'll go over very briefly Work Manager. The important things to know about Work Manager is that it's basically Android has been around for a while, and there used to be a lot of different ways of scheduling repeating tasks in your app, and this kind of ties in with repositories because you might want to have repeating tasks for example, updating your data. Maybe every 30 minutes you want to go to the web and see if there's any updates that you want to download. Well, you can use Work Manager to kind of kick that process off. But there were a lot of different ways of doing that before, and with every few versions, they would kind of update the way that you could schedule jobs and repeating tasks, but they weren't always compatible with previous versions of Android, and so yeah, they kind of replaced all that with the Work Manager. And Work Manager, you just write how the task that you want to run, and Work Manager will figure out which library that your system has to actually use to do this. So it's basically if you see a lot of different things, if you need to do something like this and you are on Stack Overflow and you see references to a bunch of different ways that aren't Work Manager to schedule stuff, you're probably looking at some older Stack Overflow posts that are talking about these libraries that are kind of not really deprecated, but it's still in use. but Work Manager will kind of handle that part for you. So you only need to kind of define the actual things that you care about with Work Manager. Any questions on Work Manager? I just wanted to mention that, you know, if you wanted to do something like this, you will run into the issue where the web will tell you a lot of other things just because it's just out of date. So try to use Work Manager for all of that.
Manager is kind of a different APK, a different program. It can be a little tricky, but services which would be inside of your own code base, they're not allowed to keep running after the app goes into the background. While the app's in the foreground, you can keep it running. If you set the service up to be foreground, you can keep it running. That makes Work Manager really important.
Yeah. Yeah, for example, in that case where you want to say, oh, let's download some new information from the web service, and you know, you can also use Work Manager to kind of have fine-grained control over, and kind of do retries and, you know, have different threading strategies that we have there. Okay, so second to last topic, material design. I'm not really going to cover a lot of information about material design because this is its own kind of talk in and of itself, but I do know that they kind of covered it as a topic for this session. So material design is basically a design language. It's basically common UI components that you can use to represent different things that your app wants to present to the user. And you know, if you take a look at a lot of Google apps, they kind of they fudge it a little bit, but they're trying to follow this material design where, you know, buttons have a consistent look and buttons have a consistent size so that it's easy for people to tap on them. And you have, you know, you can define your fonts and you do all this kind of theming stuff. The one thing that I wanted to mention with material design, there's a lot of things that, a lot of UX stuff that you can kind of go in and explore. And if you want to kind of look at how to theme your app, that would kind of, you know, go into material design, because material design defines, you know, different sizes of text and whatever else. But the reason why you want to use material design, and this is becoming a lot more an important of a topic, is accessibility. If you kind of follow a lot of these guidelines that material design dictates, an added benefit of it, and probably a reason that you want to follow something like this, is because there's a lot of tooling around accessibility that a lot of people use, but not everybody necessarily tests for. For example, if you're not dyslexic, that might not be the first thing that you think of when you're looking at your you know, whether or not your text is laid out properly on the screen. And so you want to follow kind of these guidelines so that when people do activate these kind of accessibility features in Android, and I highly recommend that you go into kind of the accessibility settings menu and kind of take a look at what kind of things that people might be using. I think a lot of common things that people use that for is screen, like font sizes, because you know, it's hard to read a lot of text on screen, and so a lot of people will bump up using these accessibility settings to the next highest screen size, and you can run into issues where things are just completely out of alignment because there was no kind of design guideline that were being followed, you know. So there's a lot of other things to go into with material design. The other thing that I would highly recommend is take a look at the example code base that they provide in some of these, and go into the values folder under XML, and just take a look at how you know, your themes and styles and fonts and all that stuff are structured, because it's much easier in your app to say, oh, font size large, just whatever font size large I specified, just use that value, so that you can change it all at once in one location. But also, you know, having that stuff kind of laid out properly also allows you to implement things like dark mode, light mode a lot easier, because it has those kind of it has API calls and mechanisms to help you do that kind of stuff. So if you really want to have a nice polished looking app that's consistent, use theming and try to follow some of the like the file structure in the XML folder that a lot of these examples have for defining themes and styles. That's the most compelling reason to use Material Designer or any of these kind of languages. But yeah, it's its own topic, and feel free to ask any kind of question around material design and and how these components are used. Finally, the last thing that I believe that they mentioned in the curriculum is testing. This also is kind of a big topic, and when we so we are already in the process of kind of coming up with the next set of courses that we want to teach people, and testing will definitely be one of the major topics. But I did want to mention, from a very high level overview, what the different parts of testing are, because one thing that is easy to get confused about when you're looking at Android testing is just how many different libraries and how many different ways you can test. And this here, this is not my work. This is originally made by another Android developer that does a lot of teaching, Chuki Chan. She has a Twitter. She has a Twitter presence, and she does a lot of. She also is a good resource for learning about stuff in Android, because she's also an excellent teacher. But she created this grid that kind of explains everything that you kind of need to know. And I'll try to find a link to this, and I'll send that to everybody. But yeah, these are the different types of testing that you want to do, and which are the libraries that you kind of want to use in order to do that. And like, so you start off with, and this is also kind of like, it also what I like about this is it also provides an order in which you should worry about these things. Like, for example, if you have no tests whatsoever and you want a place to start with unit tests. Unit tests are the smallest components. Basically, you're just testing individual methods or individual classes, and just making sure every little part of it works. And you're just testing the logic of each individual unit. And then once that all of your units are working together properly. So sort of, if you want to apply this to repository, you would have individual tests for each of the API calls that you could make, and making sure that they return the right data that you want. Same thing with the database. You want to be able to test, oh, if I ask for this, I will always get this back. Same thing with your logic components too. Like when I want to do some math, and I want to make sure that that math is right, or some sort of calculation or some sort of processing that you do on your data. Test those components first, and then once you're sure that those components work, then you can move on to instrumentation unit tests, which kind of combine a lot of these components together and say, oh, when I do this to a bunch of these components, do they all work together correctly? And then once you are sure of that, then you can kind of move on to automated UI testing, where they can go through and click things, where you can tell the testing framework to go through and click things and kind of mess around with your UI like the way your user would, and make sure that the screens that you're getting back are the correct ones. And in order to make sure that that's all working and automate that process, you can use Espresso UI Automator. So you can start with your unit tests, then you go to your instrumentation tests, and then you can move to your UI tests. And that's a kind of a good way of approaching testing, because it allows you to go from the smallest components first, figure out all the problems there, then make them work together, and then tie them with the UI. So this hopefully encapsulates Android testing in a very, very, very high level overview. And each of these can alone is its own talk. So yeah, that's everything that I wanted to discuss about. I don't want to keep you all night, so let's move into the demo phase. Anything that I've talked about, please, if you have any questions, if you have any concerns, ask away. Do not hesitate. Believe me, we've all been there before too, and that's why we give back to the community, because we don't want you to have to suffer the same way we did. So thanks everyone for listening to me ramble. Yeah, and let's see what you guys have been able to kind of do with all this.
All right, for demos, we've just got a couple of people who signed up, and it reduces the number of people in competition for the prize. So we're going to go in order of how the forms were submitted, and that means that Ife, you're up first. I got a couple of questions that I want everybody to think about and kind of try to answer when they're doing their demo. And that's, what'd you make? Show me what you made. What was hard? Was there something hard? Was there something easy? And big number 3 is, are you putting it on the Google store? So if I take it away, you can take your turn presenting. I think you should have permission, unmute, and tell us about what you've done.
Thank you, Elizabeth. So I made a mini game. I'm about to share my screen here to demo the mini game. So I wanted my game to be based off of an API, and one of the APIs that I know very well is the dog API. So the dream was to have it be based off of the dog API, but I didn't have time to do that. But pretty much, it's pretty simple. It's guess that Doge. How well do you know your dog breeds? I don't have a dog myself, my friends do, and I've always wondered if I could really get down to knowing what the dog breeds are. So it starts with this simple page. You click start, and then it gives you 4 dogs to choose from. And then you try and, from this list of dogs, yeah. When you click on one, it highlights it to let you know which one you're choosing. Does anyone know which is a boxer dog?
The boxer or
Yeah.
the bottom?
If you go a little bit down, I think it's this one here.
Yeah.
Now you click submit, and boom. Oh, no. So we got a bit of an error in my code. That is the correct dog. You are right, but it's saying it's not.
Offset by 1. I've seen that problem before.
I know, right? Okay, so we've got one more question, which is the Vizisla dog. Does anybody know?
I don't know. That one? The nose?
Any.
Just click it. Choose this one.
I do that when I don't know the answer.
Select it. So if it's not correct, it puts a red around the not correct dog and the green around the correct dog. So this is the correct dog.
Wow.
So that is pretty much the app. So that's the first question. The second question, I forgot what the second question was.
What was hard? What was easy?
So there were a few things that were hard. One was, at first I was trying to put it all within the constraint layout and trying to make it all fit on one page, but I ended up having to use the scroll layout, and it doesn't really allow for constraints. So you can see here, I can't really go all the way bottom to see this dog. That was one of the hard parts. The other hard part was, and luckily it wasn't so hard because I made mine very small, but maintaining the states of the different page, because this is all just using one main activity, because I didn't really get all the way through all of the other code labs to figure out multiple pages. So I just kind of used state management and a lot of variables to be able to have it functioning, which obviously leads to some errors here and there.
I think you
Especially
want
with
a
the
view model.
Yeah, I
Round of
would.
applause. Round of applause. And what about plans? Are you going to put on the store?
So the hope is if I can actually get it to maybe use the dog API and go through the full code lab to possibly put it on the store, because it is a simple app and I'd like to have it on my own phone to just get a bit more understanding about dog breeds. So that's
Yeah.
it from me.
Round of applause. Round of applause. Very good. Very good. Thank you so much. Thank you for showing off. I'm really grateful that you were willing to share. And now let's see. Michael, did you back out? What happened? my sheet went crazy. Yeah, okay. We've got Michael and then Aaron. Michael, are you ready? I don't see Michael here anymore. Maybe he had to cut out. I don't know. That's weird. Just checking to see if maybe his.
Hey, I am Michael.
Oh,
Sorry,
there you are.
yeah, Michael's my real name, but I am not prepared to present, so I am backing out.
All right, it's cool. I'm not, no judgment here. And now we have Aaron. Wow, Jalilaj. Are you ready? Aaron. I think you are ready. But are you muted? You are muted. Are you talking?
Okay, great.
I hear you now. I hear you now. Were
Let
you
me
sharing?
share. Yes.
Yeah.
Okay, great. So do you see my screen?
Yes. I like that picture.
So I made a simple app, because normally I started like coding for myself just for, fun, couple of years, something like that. So the app that I made is a tour operator app. I coded this one in Kotlin. It has fragments on the main page. And when you swipe, it opens, the hotels, then restaurants of a city or a country if you'd like to. And then, when you click, it shows the different it crashed.
I
That's
like the
fine.
tabs. I like the.
Thank you. I mean, earlier was
You
not
can
supposed to
restart
crash.
it. Okay. Did you have a question about the crash or?
So
What was
when
hard?
I tried
Yeah.
before was not crashing, to be honest. So I don't know what
Yeah,
was the crash
always
for.
when you have to present, this happens even at the big conferences. So don't worry. If
Really?
crashed. Yeah.
That's fine.
If that makes you feel better, they have always a backup demo.
So let's see if it's going to crash again or not. And so this one, I implemented a category fragment adapter with all the fragments when you switch to the position, and then different.
Was that a view pager?
A view pager, correct.
Awesome.
And then when you scroll to the different fragments, I implemented of the click listener, and then it's going to, I'm passing intent here instead of, a view model, because I'm not used to the new architecture.
Some hard-coded strings, internationalization, externalizing the strings and doing localization, accessibility. Those things make a good app great, and you guys are crushing it. So, Aaron, are you going to put that on the store?
This one was just, for fun. Probably I'm just going to work more on it, and then maybe I'm going to give it to a friend of mine that she has a tour operator, so she can maybe just publish it for herself in the Google Play Store, or I can do it for her. Okay, it's working.
There
Great.
you go. Nice.
And then you have like a scroll view, a nice scroll view, and you can send an email if you'd like to, to the tour operator, so you can book a tour there.
Well done. Well done. So we got 2 demos and 3 prizes. So another round of applause for Aaron
Thank you.
showing off. Thank you. And if you guys both have a US or Canadian address, then you're both winners. I think, we got 3 prizes, 2 demos, and then we got 1 door prize.
Great.
Now,
Thank you.
looking at the form, I got 14 names, and I'm going to share my screen, and I'm going to share my wheel of names. So tonight's prizes, I typed it up, but I'll say it out loud. Tonight, you guys tell me if you want to have earbuds, I can give you those, or a Nest Hub, with the screen. It's the assistant with the screen instead of the little mini. That's what our prizes are. And so we've got 1 more prize to give away. This is the last door prize of the Android Study Jam. And I've got 14 names. So drum roll, drum roll. Here we go. We are almost ready. This is near the end. I want to thank everyone once again for showing up. I really appreciate the work that you did. I think that y'all kicked butt, and I want to thank Aaron and Ife for showing off their work. So here we go. I'm going to click to spin. Are you ready? Clicking. Here we go. Let's see who the door prize winner is tonight. Roger. Congratulations, Roger. Woohoo! But everybody's a winner tonight. So if you fill out the form and share your snail mail address with me, then I will be happy to send you a printed certificate of completion along with some lovely Boston Android stickers for your computer. If you want to turn on your camera, I want to do a group photo. So we're running a little late, but I'd like to get one last photo of the group tonight. Say goodnight, Gracie. Good night, Gracie. That's like old American television joke. But yeah, I hope that we got you where you wanted to be with some of the techniques for programming Android. I'm going to do 2 screenshots. So let's count down. 3, 2, 1. Cheese. And then let me do it one more time. I'm hiding the chat this time so your faces are bigger and prettier than before. Are you ready? 3, 2, 1. Oh, wait. I'm not ready. Sorry. One more time. Here we go. I'm for real now. 3, 2, 1. Cheese. All right, cool. So thank you everyone for showing up. Our next informal Android meetup is 1 week from tonight. We've got a few more before the year's end, and then we're going to take some holiday time. Our informal Android meetup runs every other Monday. There's a few conferences coming up. There's the Android Summit with the Google Android team at Google. There's the the Droidcon New York City in November. So you can look that up. I may get myself a ticket and show up in person for that one. Thank you everyone one more time for coming. I want to see you on the Slack. I want to see you at the informal. And that's all I got. Yes, Chris, Droidcon is on for November. I don't have a link, but it's pretty easy to find if you Google it. It's going to be in Brooklyn, and it's probably going to sell out. I don't think he's selling as many tickets as he could. I think the speaker window is closed, but you can get tickets and you can volunteer too. I'll be sharing last week's recording and this week's recording on the community site. And yeah, keep going, keep working on those code labs, okay, friends?
Have a good night, everybody. Thank you so much, Liz and Jean, for the great workshop.
You're welcome. Thank you, Linda.
Thanks everyone for attending.
Thank you.
And I'll be in touch with the winners. Thanks for the demos. I will get your information from the form and touch base with you. And you can look for your stickers in the mail. Woo, woo, woo.
Good night. Bye.
Good night.
Bye.